the invitation here today. I'm Loulou Dickey. I'm the Executive Director of ISWEP, and I'm here with Pat Sauer, our founder. And so we're presenting today some information that was extracted from our training, the iSalt training, so the Iowa Salt Application Leadership Training. And that was developed in coordination with the Iowa chapter of the APWA, as well as the Professional Snow Fighters Association. So this is just kind of an abridged version of that. And I'm going to quickly go through some background, and then I'm going to hand it off to Pat. So we're going to talk about the environmental impacts, regulations, and level of services related to road salt. And so just to kick things off, we want to understand why road salt is an environmental concern. So road salt is typically sodium chloride, and it can be very toxic to aquatic vegetation, fish, frogs, turtles, and other wildlife, especially in high concentrations. It can also kill plants and trees, especially aquatic plants, when the salty water is absorbed through their roots. And salt-laden soils can lose its ability to retain water and store nutrients. And chloride also corrodes our infrastructure, road surfaces like bridges, and increase our maintenance and repair costs. So some of the challenges with chloride include that it is clear, so it dissolves in water, it can't be seen. So water may look really clear and clean, but it could still have a high concentration of chloride. Chlorides also don't break down, so they accumulate in our groundwater and our water systems and our soils, and there isn't a natural process to remove them. Filtration of chlorides is generally not cost effective. So if you think about desalination, it can be very expensive. So we want to avoid that situation where we're getting to that point. We also know that if we oversalt our streets, parking lots, and sidewalks, that can account for a significant portion of chloride pollution, especially here in the Midwest where we have cold weather. Salt definitely dissolves very easily in water, which means it's very mobile in our environment. And excessive amounts of liquid deicers can also contain carbohydrates, and those can decrease the oxygen available in our water bodies for aquatic life. So thinking about chloride specifically in Iowa, we are seeing increases in chloride concentrations in our water bodies in Iowa and across the whole US. We do have water sampling that's conducted here in the States by a myriad of groups, including the EPA, the Iowa DNR, the USGS. We also have a group in Polk County that conducts water sampling as well. And there are also other sources of salts in addition to road salt. So if we think about things like home water softeners, filtering from water plants, and also industrial processes that use salt, those are also sources that can introduce salt into our surface and groundwaters. So looking at the monitoring data from the Polk County Conservation Monitoring Program, we can kind of see the situation on the ground with chloride concentrations in our local streams. So when we see those red dots, particularly the large red dots, that means we have a really high concentration of chloride, and this is a 5-year average. We can see that those high concentrations are primarily dispersed throughout the southern portion of the metro, but we do see that higher concentration up here in Ankeny as well. So we know that this is also a problem locally. There is monitoring that is conducted across the whole US. So the Isaac Walton League of America, they organize volunteer events where folks will go out and collect water samples and do chloride testing. And so they're kind of keeping track of these concentrations across the US. And what we see over time is that concentrations in our surface and groundwater are increasing over time. So we're seeing more and more salt building up. The USGS also released a report on road salt use. This is a 2014 report. And so they found that 84% of urban streams that were studied had chloride concentrations that increased substantially over the study period from 1960 to 2011. And there were numerous streams in the study that exceeded concentrations that are toxic to aquatic life. These concentrations were highest during the winter, but they also increased during all seasons over time, especially at northern sites. And that's because that salt builds up in our soils and can be flushed out during rainstorms throughout the season. And then streams with the lowest concentrations of chloride were in watershed with small amounts of urban land cover. And we know that's because we're applying those road salts, especially in our urban areas where we have lots of traffic and cars. Thinking about water quality standards, especially in Iowa, we do have a water quality standard for chloride, and it provides several different standards based on maximum contaminant level for drinking water, chronic and acute levels for aquatic life. And the goal of these standards is to ensure that all Iowans have surface waters that are fishable and swimmable, and that water resources are being protected to put to their best beneficial use. So looking at our standards here in the state of Iowa, these first set of standards are going to relate to aquatic life like cold water species, as well as fish and game populations. And then we have our drinking water standard, which is our maximum contaminant level. And that drinking water standard is 250 milligrams per liter. So remembering that number, we can see this is some data that was collected by the Iowa DNR. They did surface water monitoring over time in the state of Iowa for chloride concentrations. Again, this is milligrams per liter. And so that red line represents that 250 milligram per liter maximum contaminant level for drinking water. And what we see over time is that standard is often exceeded up to over 10 times. So we can see that these chloride concentrations can be quite high, and they are pretty seasonal over time. So we see those kind of flashy concentrations that usually come down again in the summer months. Thinking about how wildlife is affected by chlorides, we are in a freshwater system here in Iowa, so our lakes and streams should have naturally low concentrations. So we're looking between 100 or between 1 and 100 parts per million. So we want to see those lower concentrations that can support aquatic life. However, there are some species that are adapted to more higher saline concentrations. So if we think about our ocean fish, those can survive in concentrations of up to 35,000 parts per million. And this can be important because as our waters get more salty, they can get to the point where they really can't support our native wildlife population, and things like invasive species can more easily take over in those saltier environments. Chlorides also have a significant impact on soil. So this is particularly true in urban areas where we have things like sidewalks and pavements right next to vegetated area that can easily migrate over into that area and get into the soil. And so salts can destroy the structure of the soil, so they actually kind of replace some of the natural minerals that exist in the soil, and they cause the soil to lose its ability to kind of clump together and become more dispersed. And so what that leads to is more compaction of the soil, and there's less pore space available in the soil. So there can be less infiltration. There's also less space for the oxygen that plants need to uptake. They also change the chemical makeup of our soils and reduce the number of nutrients that will be available to plants and other microorganisms in the soil. So we can see that there are effects, especially on our roadside vegetation. These can be get so bad that it completely kills off all the vegetation. We've seen that trees and other plants are completely killed off if the salt concentration gets too high. It can also accumulate on the plant materials of the plant, so things like leaves and branches that would get on there from splashing and spraying on the road. And it can also scorch our leaves. So if you've ever seen kind of this effect where the tree has this kind of scorched color on the tips of their leaves, that can be caused by salt pollution. Salts also impact our infrastructure, so they can damage metal surfaces. They accelerate corrosion and oxidation of metals. De-icers can also promote the leaching of components of cement, so they can cause these issues with cement here that we see in this photo. They can migrate through the cement to make contact with the reinforcement steel or rebar, and that could cause corrosion. We can see the effects here of oversalting on some cement surfaces. So this causes softening of the cement, which can then cause this spalling and separation of the aggregates. They also can break down in the cracks or crevices and cause disintegration, and cause flaking and scaling of concrete surfaces. Salts also get into our groundwater, so this is a big issue when we think about how salts move through the environment. So as salt dissolves in water, it gets into our groundwater and it flows over time towards our streams. Also, it can build up in the soil, so then we see those flushing effects during rain events. And these can have a big impact on our groundwater, or our drinking water, because a lot of our drinking water comes from groundwater sources. And so if we have built up concentrations of chlorides in our groundwater, that can affect our drinking water quality as well. And it's important to note that chlorides can also mobilize other pollutants. So we're seeing things like heavy metals being mobilized, things like radium that are naturally existing in the soil are mobilized when the chloride concentration goes up. And so that can also have an effect on our drinking water supplies as well. Other than just the groundwater pollution, salt also goes directly into our water bodies, and that occurs through our storm sewer systems. So if you think about snow melt during the spring, there's going to be a high concentration of those salts on our roadways, and as that water melts, it's going to be flushed into our storm sewer systems. Those systems go directly into our stream with no treatment, so all of that salt will end up in our local water bodies. And that is important when we think about how these systems are regulated. So our MS4 regulations, many of you are already familiar with those. So that applies to our separate storm sewer systems. And we have regulations in the state of Iowa. So there are 44 cities and 3 universities that are regulated under these MS4 regulations. And this is under the National Pollutant Discharge Elimination System, which is a part of the Clean Water Act of 1972. And so that means that these systems are required to be permitted and regulated as a point source that discharges into the waters of the US. And so when we think about point source, we're thinking about things like pipes that discharge directly into our streams. And then we also have sources that can be a non-point source. So that's more of a diffuse source like runoff. We think about that more in our agricultural areas. And thinking about how those regulations would affect our chloride use, we think about our 6 minimum control measures. So this is really going to come in with our third control measure, the illicit discharge detection and elimination. So that can apply to things like plumes of salt that could occur from spill or salts that are left out in the open and dissolved when there's a rainstorm. And so those illicit discharges are really important to control because that can trigger fines and other regulatory actions. We also need to think about it in terms of our pollution prevention and good housekeeping minimum control measure, because that can apply to things like application rates and equipment calibration, as well as our staff training. So thinking about our illicit discharges, again, those would be kind of the large concentration that's released at once if you're thinking about a plume. That common sources of those can be things like salt piles, concrete washouts, which have different types of salts, soaps and solvents, as well as other things that may be stored outside that could be exposed to rain or ability to wash into our storm sewer system. And then thinking about our good housekeeping and pollution prevention, we need to think about how we're applying salts. So we're thinking about discharges of contaminated solution into the city's storm sewer system, So we know that the salt is susceptible to dissolving during storms. So we want to make sure that we're storing it in a watertight storage container that isn't exposed. We also need to think about how we're preventing leaks from liquid de-icers as well. So inside storage is generally best. We want to make sure that's covered and contained, set on some kind of impervious foundation surface. And thinking about how these regulations are enforced, the EPA has ultimate authority over the program. But that is enforced by our local DNR. So we have 6 field offices throughout the state, and those field offices have the authority to enforce these regulations related to our minimum control measures. So we need to think about how this affects different city departments. We know we have our Public Works Department. They may be in charge of the storage, handling, and application of our salt products, excuse me. The stormwater program within our city is also responsible for permitting, for maintaining that permit and reporting. And then we need to make sure that we're communicating with our public, doing some public education outreach to raise awareness about salt application. And then any businesses or contractors that apply salt, we need to be communicating those best management practices to them as well, because they can be a large source of these pollution events. And so if we have a contractor that's applying salt, they can be responsible for an illicit discharge as well as our residents. And then basically the bottom line that we want to communicate is to use only what is needed to achieve the desired results. So we want to make sure that we're not over applying, and that's important to communicate because many contractors worry about their liability. So making sure that we're communicating with them about the correct application rates is important. All right, Pat, I will hand it off to you now. I'm going to stop sharing.
Thanks, Loulou. In the meantime, we do have a couple questions I'll go ahead and ask. How does the presence of chloride in soil decrease the available nutrients to plants?
So my understanding, and Pat, you're the soil scientist, so you hop in, but I think it has to do with the chemical bonds between the minerals in the soil. And so the salt can actually replace the bond between the soil and the other minerals that are needed for plants. Is that correct, Pat?
That is correct. Yeah, through cation exchange, anion exchange. Yes. Sorry, I was having to focus.
Thanks.
And I'm assuming you can see my screen.
Yep.
I know I'm not ready to start yet, but you can see my screen. Is that correct?
Yes.
Okay, thank you. Go ahead.
They're also wondering if these slides will be available later, if you can possibly email these to me and I can distribute to those who are registered.
Yep, we can do that.
Okay, thank you. That's it for now.
Okay, so here we're going to focus for a short bit on private contracts. So I've learned a couple of things having put this training together and conducted the full iSalt training. Is I was surprised contractors typically have no training, are very, very minimal. I'm not sure where they're getting their training from on salt applications, rates, as well as guidance that we will get into. And there are some cities that as well, their staff have not been training, and some city departments, maybe even your departments as well, hire contractors to apply not to roadway streets, but parking lots, clear parking lots, and maybe adding salt to those surfaces as well. So one thing is to be aware of. One thing that where a change can occur is looking at the contracts between a private contractor and a business entity or city or county. So some of the contracts can pay by the amount of salt to de-icers. More is better, right? Wrong. So as a result of that, we end up with a lot of over application of salts. Excuse me. And then as a little side note too, and I shouldn't add too many of these side notes because it'll gobble up too much time. We had a training event in Marion, and there was a facilities manager from one of the local hospitals, and he had said that he was told, because he oversees the maintenance, snow plowing, et cetera, salt applications on the parking lot areas, to more is better, add more and more and more. And all of that's related to liability issue, but more is not always better, which you will see here. So looking at revising those contracts to make them focus on outcomes rather than inputs. So, and a lot of this really, this is contractors, others that are applying these salts, de-icers need to know how they work. They need to know about road conditions. They need to use recommended application rates, and they need to calibrate their equipment as well. So, and then looking at an expectation on levels of service. Looking at the different scenarios here. Do you want all your roadways to look at the bottom right image? Or maybe some of the The smaller side streets, maybe we can tolerate the top left photo. So looking at a city policy and starting to think about this, what we're trying to get away from is this. So is a gross over application. And you know what the starting point should have been in this is you don't just go out and throw salt on snow. You shovel it first. So, um, closer look at services provided by contractors, snow removal, plowing and shoveling, salt and de-icer application, and even sweeping up excess granular form of salt at the end of the season. Think about that. So, and this is I won't go over this in heavy detail, but this is an example extracted from Minnesota's Smart Salting program, where all of their contractors in the state are required to go through a training program. And so, look at some of the language here. The contractor exercises judgment as to snow and ice management, the materials that are used and the application rates, et cetera, based on weather conditions. So I'm just going to go through that fairly quickly. So may want to look at city policies, even for those of you that are professional, have businesses and parking lots. Think about your contractors. Ask them, hey, what application rates are you using, and are you calibrating your equipment? So what I'm going to do at this point is I'm going to give you highlights of this training program that we have developed. So the goal of it is, there's going to be an education component, but you're going to see what the content is, which you may find is relevant to your operations. So this is designed to help salt applicators improve their bottom line and reduce their environmental impact by providing expert guidance on application rates, equipment calibration, material handling, and weather monitoring. So we look at how salt impacts the environment and regulations applicable to reducing pollution. Loulou went over that. We'll learn some methods on properly transferring and storing dry and liquid de-icers. And understanding how salt works and de-icers work is really important. Getting into some recommended application rates, how to calibrate equipment, and then weather forecasting and pavement temperatures. So some general information and storage or transfer of salts. So there's great guidance available from the Salt Institute. And, thinking about, I think most cities, counties do this now, is covering your salt storage, having a shed or a building that is available, so corrects salt storage. And then thinking about de-icer storage as well, having secondary containment and such. So how do they work? So actually, and I need to minimize because I can't see my full screen here. I need to minimize this image. There we go. Okay, so they must be able to lower the freezing point of water or the melting point of ice. It would be nice if they do it quickly. They're cheap, readily available, causes no or very little environmental harm. It's easy and safe to handle and distribute, can be stored safely, and can be placed where we need it in the right quantity at the right time and kept there until it has time to work. Guess what? There is no perfect de-icer that does all of these things. Whoops. Okay. There we go. My slides just decided to not advance. So there is this nice table that shows you, look at the relationship between temperature and the pounds of ice melted. So look, warmer temperatures, you're going to be melting more ice. When you start getting to the really low temperatures, -6 degrees Fahrenheit, look at the dramatic decrease in melting of snow. So keep that in mind. Here's an important bit of information. When we talk about salt and temperature, the temperature is not the air temperature, it is the pavement temperature. So any reports put out by your local TV, radio, that is all air temperature. It is not pavement temperature. So number one learning point. So also knowing there's a dramatic reduction in salts melted as it gets colder. And it takes a lot longer to melt snow/ice the colder the weather. So salt or any other de-icer is not used to melt the snow and ice. It is used to break the bond between the snow and the pavement. And Wilf Nixon comments on, he provided this information, it's bond, break the bond, not James Bond. But anyway, so why does the breaking of the bond matter? So the number one tool for removing snow and ice is the snowplow, mechanical methods. A well-applied de-icer makes plowing a heck of a lot easier, more efficient, and it reduces substantially the snow and ice left behind after plowing. So at the very least, that bond should be broken. So, and it's a lot better if we're using fewer de-icers. So you have three choices for de-icers: solid, liquid, and a solid that is pre-wet. Concerns about some of the dry solids, and I've seen this driving behind some from snow plows, is that there's a lot of bounce and a lot of scatter. So a lot of that product is not going where it should be. So this can result in about 30% of the dry material bouncing straight into the ditch. Do not put de-icer down dry. So the technology, they've learned how to pre-wet the solid form. So you can buy pre-wetted treated solids. Some products are salt coated in a liquid, which can be stored in its coated condition. And by the way, bounce and scatter is not the only reason to add liquid to your de-icer. The other reason is, oh, what the heck is happening here? There we go. Whoops, is you activate, there you go, the liquid or the water activates it. So remember we showed how long it takes for salt to melt ice at the lower temperatures. A lot of that time is the salt going into solution. So when the salt is wetted, you're jump starting this solution process. So as a result of that, you're going to need less salt. So why not just use liquid form? You can, but guess what? You're going to need equipment enhancements in order to do that. And there's some drawbacks to be aware of before you take the liquid only plunge. So some agencies are making some of their routes liquid only and have had a lot of success. So there is the anti-icing and pre-wetting. So I think a lot of you have seen when you go down a roadway, some communities are doing this process already. They're anti-icing, so they're spraying the brine on the pavement surface prior to an anticipated storm. So this is just some additional information to take a look at. So looking at other chlorides, sodium chloride, most commonly used, the cheapest chloride that is being used. Calcium chloride is also used, and magnesium chloride, commonly called mag chloride. So sodium chloride is a salt that we can use either as a solid or liquid brine, 23.3% brine. And magnesium chloride is also a brine. Calcium chloride is almost always a brine, but it's available in flake form as well, but not used very often. So guess what? The sodium chloride is the cheapest of the three. So the non-chlorides are potassium acetate and calcium magnesium acetate. They don't have the corrosion properties of chlorides, but guess what? They can impact water bodies as well. They can create an oxygen demand, which will impact your aquatic life. And then there are the carbohydrate product. Some of you have heard about beet, soy-based products. Excuse me, they're carbohydrate based, but you also typically they're being used along with a chloride brine. So here, the quantity of carbohydrate can vary from as low as 5 up to 40%. They enhance the longevity of the product on the pavement, but you're not getting rid of the chlorides. Equipment, application, and calibration. So when you're looking at equipment, what type of product? Granular equipment or salt brine equipment, and then application rates. What is the least quantity to achieve a given goal? And then calibration. Yes, you can calibrate equipment used for when you're using granular sodium chloride or brine. So when looking at equipment considerations, use of granular salt on roads, sidewalks, and parking lots. So smaller application, they're hand spreaders, they're walk behind spreaders, UTV spreaders, slide in Spreaders for trucks. I think we've all seen these, although I haven't seen anyone use a hand spreader. Often, what we really are trying to get away from is having that pail of salt by the front entrance and having a big cup or scoop out there. And, it's just massive overloading of chlorides. Liquid or brine applications. You're looking at spray nozzles for sidewalks with a streamer nozzle. Excuse me. So this is what we're trying to avoid is, there's no following of application rates. We're thinking more is better when indeed it's not. So a lot of different equipment, slide-in spreaders on a pickup, and then we've seen this single axle and tandem dump truck for roads. And for liquids, yes, you can take it down to a small scale sprayer, and there are truck mounted systems available for smaller applications for contractors. Application rates need to make adjustments when needed, rates for salt, rates for liquid. And you need to make adjustments when needed. So here we're looking at, here are the variables: pavement temperature, moisture and precipitation, cycle time, and then also grip, pavement type, etc. So need to be aware of those when you're going to be using more salt or less salt and the pavement temperatures. Shown here is some guidance for application rates that if your city or your business is not using recommendations at all, I'd highly recommend that you go to the Minnesota Snow and Ice Control Field Book. This table was taken directly from that because I couldn't find one for Iowa. So use this one as well. And so we're seeing different pavement temperatures, weather conditions, and looking at salt pre-wetted, pre-treated with salt brine, salt and other blends, dry salt, versus when you might consider using abrasives such as winter sand. So a very useful starting point for anyone. You can also, brine solutions can be made, so your contractors can make brine solutions. So there's nice guidance available put out by New Hampshire and Connecticut. They have a BMP guide that is available. And then even brine application rates for pickup applicators. So this is pulled from Minnesota. So mag chloride, salt brine, other products. Here's road salt application rates for roadways. So looking at the temperatures and weather conditions as well. And it is going to vary. Not every weather condition is going to be the same, if you have sleet, snow, and such. So liquid application rates for roadways. So if you're using salt brine, sodium chloride, use 30 to 50 gallons per lane mile prior to a storm. If using magnesium chloride, here's the recommendation. And so there's some YouTube videos for guidance. Why do we want to calibrate? So that was application rates. Now we're getting to calibration, which is really important as well. You want to minimize over application, environmental impacts, and it'll be cost savings, inventory control. So the equipment needed, we won't spend a lot of time on this. So you want to you need to scale away the salt collection device, marking device, and then secondhand. So I don't have time to go into a lot of details, but you can calibrate any equipment, including a walk-behind spreader. So it's just something that should be done. I know a number of cities, counties do this routinely, but I've also found out some are not. So, finally, weather forecasting and pavement temperatures. So I talk about the importance of it's based on performance of the salts, de-icers, and even the anti-icing process. It's based on pavement temperature. So here are your options. Yes, you're going to get National Weather Service information, but that is air temperature. It is not pavement temperature. So IDOT provides guidance, which I will show you, and this needs to be shared with contractors and city staff. There are also paid forecasting companies. There are apps, there's software that is available as well. And I know there are some of our member cities that are using that. So shown is IDOT monitoring. So they have these different monitoring. You just go to IDOT's website and can obtain this information. If I can do it, you can do it. But there are different monitoring sites across the state. And guess what? We're seeing this table that has road temperatures. And they're telling you the location, precipitation, sky conditions as well. Bottom line is the recommendation from the industry is anti-ice before the storm, if possible, because you're getting at trying to prevent the bond from forming. Use pre-wet solids if solids are used. Make sure the application rate is suitable for the pavement temperature and the storm type being addressed, and we provided tables of that information. When the level of service is reached, guess what? Stop applying material. And then, of course, make sure the equipment is calibrated. Otherwise, the quantity of material handled, you don't know. So we do offer this training. We've done it well, I'd say about 3 or 4 times. So West Des Moines, City of West Des Moines was the first city to hold this training locally. Typically, we come in and do this in person, and city staff are there and maybe Parks Department staff, as well as we try and get some of the contractors there, and any maybe big box store that stores and hospitals that hire contractors. So we do have an event in person on March 6th in Coralville. We don't have the venue yet, but Lulu's getting really close to getting a response back from the city of Coralville. Wilf Nixon will be teaching that class. He is the guru, one of the gurus in Iowa for salt application and winter applications. So we typically do this in person, or we can do it webinar based. And we are looking at in the near future of creating a on-demand training. We'll break this up into modules because some of our members have said, hey, some of our staff can't sit down and watch the whole thing. It's about 4 hours worth of training, but they could watch parts of it. So you can gain more information at iowastormwater.org. And if you want a case study, I'm gathering some information from Iowa, but I just didn't get in time. But on Minnesota Pollution Control Agency's website, they promote both Minnesota and Wisconsin have salt training programs. So, because they've done considerable monitoring and they have found significant impacts on their water bodies, especially in urban areas. But City of Plymouth, they are located near Parker Lake. It's impaired for chlorides. They were one of the first in Minnesota to put a brine tank on the box of a plow. They've modernized their spreading equipment. They also have it, while a driver has control over these settings, they can be networked so a supervisor can monitor their information and just adjust the application rates. So they've come up and they don't have a blanket bare pavement policy, and they aim for bare pavement for the main roads, hills, and bridges, but for everything else, they will just scrape. So they've made this decision as a city. So they have been able to monitor and come up with, over the last 10 years, they have decreased salt use, and they anticipated in 2022, that really snowy year, they were able to spend $38,000 less on salt than what was budgeted. So with their efficiencies and changes in policies. That is what I have for you. So now I need to stop sharing. If I can get back to, I'll stop sharing. Were there any additional questions?
So thanks, Lulu and Pat, for lots of information. I'm glad that people will have a chance to attend your training or see this webinar again when it's recorded. Lulu did share information about the iSalt training in the chat. So if anyone wants to see that, there's a link there so you can learn more. There is one question I see right now, but please, if anyone else has additional questions, go ahead and type them in the chat and we will get them answered for you. So this one has to do a little bit with the first question that was asked about how the soil is impacted by salt. It says, once the bonds have been replaced with salt, will additional fresh water flush it out? Do we have a feel for how much groundwater chloride concentrations contribute to surface water concentrations?
Oh, wow, those are advanced questions. The second one, the second part of it, I think we need to do a little more research on that. My guess is they've studied that heavily in probably New Hampshire area as well as Minnesota. But I don't have that data right now. Unless Lulu, have you come across any information?
I was just looking at some research this morning. It seems like it's pretty like specific to the location and the geology, and then also like the weather conditions, and it's changing over time. And so I'm not
Right.
sure how to answer that. Yeah.
I would say, if you're in areas where there's sandier soil, you could have significant impacts on groundwater for sure. So, yeah, to be aware of that. And what was the first question about impact on soils? Because I thought we answered that, but what was the first?
Once the bonds have been replaced with salt, will additional fresh water flush it out?
Will additional fresh water flush it out? I think it depends on the soil texture, the amount of silt and clay that's there, and the nature of those clays as well in terms of their cation exchange capacity. I personally don't specialize in cation exchange capacity and probably would have to look a little more closely at that. But the bottom line is when you're looking at soil texture, I think you're going to have a lot more flush through on sandier soils. That's pretty obvious. But will those salts be released over time? Oh, that dynamic could be complicated, especially with the application of fertilizers too. So I don't have an easy answer for that one. I'd have to do some research on that. Good question.
All right. Any other questions? We'll give it 10 seconds, see if anything else pops up.
So if nothing pops up, this is really important, and I think we're making progress. And then I go to a strip mall or a large parking lot, and I just see gross over application of salt, which is telling me they're not using any recommended application rates. And I don't have no idea if they're calibrating their equipment as well. So it is an issue, and it's going to become more of an issue. So I think I shouldn't think. We need to pay more attention to it. So.
Yep. What's the best way, equipment-wise, to monitor surface water concentrations?
Oh, let's see. It can be simple and it can be more complex. There are probes that can be used to monitor chlorides, and USGS would be using that type of technology. But you could purchase from Hawk, excuse me, Hawk Chemical, not promoting any one company, but they have little kits. The Iowa Water group used to go out and monitor using some of the little kits that Hawk provides. So it ranges in technology.
I think also the Isaac Walton League will help organizations, including municipalities, organize like a testing day so you can get the public involved and go out and test. And I think they provide kits for that. You may have to pay for them if you're getting like a large amount of them. I just put a link in the chat. So
Yes, they are a great resource as well, and to engage them locally would be, I know some communities are involved in this activity already. There are some watershed groups, the monitoring, so they're familiar with some of the simpler test kits. But your larger organizations, agencies, and research facilities more than likely use a probe, or they could bring samples into the lab. That would be in-stream monitoring, in situ monitoring, or they can bring the sample into a laboratory to have it analyzed as well.
All right. Well, not seeing any more questions in the chat, I will go ahead and say that we are done. And thanks everyone for coming in to listen today. And thanks again, Pat and Lulu, for speaking. And I will send out more information about next month's Lunch and Learn shortly.
thanks for inviting us, Cassie.
Yep,
Thanks
you're
for having
welcome.
us.
Bye.
Bye.
Organizing.